don't know what's wrong with these flowers. They keep doing everything right. I just don't understand. I just don't understand why they aren't growing.
Hi, welcome back to another episode of Mr. McCune's Minute Science. We're going to be diving into a few things called non-Mendelian traits, or things that are rule breakers or opposing what Mendel's laws were about. And we had this punnett square discussion at first, and we had road jumping all over me. We were talking about blue versus silver Weimaraners, dominant versus recessive alleles, and how those color traits are inherited through offspring. We have some rule breakers and some things we got to point out and notice. The first thing that we're going to talk about is incomplete dominance. And we're going to use two flowers for example. This is really heavily researched in snapdragon flowers. Did my best representation as an artist up here on the dry erase board. So we have two different flower colors. We have a red flower and we have a white flower. Both of those flowers are going to be homozygous dominant. White being a dominant allele and the red being a dominant allele. That's not something we've seen so far. We haven't seen these two dominant things crossing over yet, and they take on a different relationship in this case where we call it incomplete dominance, where neither the red or the white is fully dominant over the other. In fact, they're partially dominant. So the offspring will be expressed by almost a merging of colors or a merging of those two dominant alleles, where neither one is fully represented, but they're both kind of blending together. So when we see this and we want to fill out our punnett square, we're going to have capital R, capital W in every single square. 100% of the offspring in this case are going to have this genotype, big R, big W. But what does that mean about the color? What kind of color are they going to actually be represented by? The flowers are going to be pink, because we are showing that two dominant alleles for the white flower and the dominant alleles for the red flower are neither completely dominant. In fact, they end up blending together, and the red and white blend gives us pink offspring. Notice how it's not half red, half white, but instead it's this blended approach. But there is a circumstance where we can get an equal representation of half of one allele and half of the other and make something either speckled or half red, half white. And that's the next concept we're going to talk about. All right, as I just alluded to, there is another type of non-Mendelian traits that get shown in some offspring of some parents. And here we have two beautiful chickens. And I know what you're saying, they're the most beautiful chickens you've ever seen. You've never seen a chicken as beautifully green and blue as this one. You've never seen one as plump and round as Janet is on the top. These are two Hollywood level chickens. So what I want to do is I want to look at the genotypes of both of these chickens. Janet over here and Carl on the left. The capital F, the allele capital F, is standing for feather, and the letter in superscript, or almost like to the power of, is indicating what color those feathers are going to be. So for Carl's sake, we have FG, showing that his feathers will have a green phenotype, or a green showing. And here for Janet, we have FW. So we have these two different colored chickens. They mate together and they're going to create some offspring. What we want to see is what the probability of each type of inherited trait is going to be. What are those offspring going to look like? As you might see already, it's going to be pretty basic. It's going to be FG, FW in all four squares. So just like we predicted, every single square is going to have the exact same genotype. And so we got to see what would that look like in an offspring, because with the flowers that we just looked at, we had this blended approach. We had red and white, and they blended together to make some sort of pink flower offspring. But here, we're going to show codominance, which is the equal representation of both allele types. So neither one is going to be more dominant than the other, and they're going to be represented equally in the phenotype. So what did we get when we crossed a all-white chicken with an all-green and blue chicken for the codominance example? Well, we have Frank. And Frank is more suited for the big screen than both of his parents because he is taking on the traits of both of them equally represented in his feather color. So he has green specks. They're called speckled chicken. Because we couldn't get our hands on a physical chicken, we had to look here. And so there are real things called speckled chicken where the alleles from both parents are equally represented in the offspring. They're both like a 50-50, and so they get this speckling pattern. You see this in horses, you see this in cows, you see this in guinea pigs and other mammals where they have these spots. or these different patterns of black and white, or black and brown, or red and brown, and you get this different mixture because the alleles, neither one of them is completely, totally dominant. Instead, they equally represent themselves in the offspring. Now, there's something called an acquired trait versus inherited trait. That is the difference between something that you were actually inherited from your parents and something that happened to you after all of your alleles were already set up. And so I have an example of an acquired trait. And this would be something like changing your hair color, changing your hairstyle. But there's also one with my dog, and he's so sleepy because he spent the morning running with his mom. He's already done like 10 miles today. Rogue, who we all know very well, he is so tired. What happens with purebred Weimaraners is they have a really skinny, thin tail. And I don't know if you can quite see his tail right now. It's supposed to be really long and skinny. And as a hunting dog, what happens with the breeders is they always cut their tails. I'm sure you've seen other dog breeds with cut tails. And now I do not condone that. My wife and I did not cut his tail. It's not something we chose. But with this breed particularly, they cut the tails of Weimaraners because they would break really easily. They get caught in briar. He's supposed to be a bird hunting dog, so if they got caught in the woods, it'd rip off. So what they did was they docked his tail down to about 5 inches. And so this is an acquired trait. He inherited the trait for a long, thin tail. Post-development, he had his tail cut. That would be an acquired trait, something that was done after the fact and isn't in line with the heredity from your parents. Oh, he's so sweet right now. You guys saw him barking and jumping at me and biting me. You don't get to see this version of my dog. Good boy. So one interesting thing is that the environment can really drastically affect traits. Now, it could be an inherited trait to have a musical ability, an easiness to learn an instrument. However, if you were never exposed to that instrument, if you never got the chance to actually play it and practice it, you would never be good at that skill. It wouldn't develop. You might have the backbone and the foundation to do it, but it wouldn't develop because you never put in that kind of work. You might be someone who has really great muscle development, muscle tone, or whatever it happens to be, and you can grow muscle really fast. But if you never pick up the weight, if you never put your body through that mechanical stress, your body won't change. You won't have that change in phenotype or the way that you look or present yourself because you weren't exposed to that type of change. Now, there's another type of change that happens with plant life too. If they're not exposed to the right nutrients, the right flower, the right environments, the right sunlight, they won't be able to grow as well as they should.
Oh, man, I don't know what's wrong with these flowers. I keep doing everything right. I keep it in the basement, away from all the light. I give it no sunlight, complete darkness. I give it all the proper nutrients that any flower really needs. 2 parts Coca-Cola, 5 parts spoiled milk. I mean, I just don't understand. I just don't understand why they aren't growing. It just baffles me. I do everything right.
If you check Google Classroom, there's going to be further examples of Punnett squares and going through heredity. Now, what I do want you to understand is that the words that we talked about today, codominance, incomplete dominance, acquired versus inherited traits, and environmental changes, those are concepts we need to know, not necessarily to be able to do anything with. So we don't need to do Punnett squares with those, but we need to know what they are so we understand the world a little bit better. I do have something in the mail that I just bought off Amazon. I'll see how long it takes to get here, but I think it'll be a lot of fun for this video. You'll have to wait and find out what I got, do a little experimentation here, and see if we can make some stuff happen. But other than that, hope you guys have an awesome day. See you later, and check out Google Classroom.